Okay, so in this question, I do have a logarithmic function, but this one does not have just x in the argument. It has x plus 3. So what do I do when it's x plus 3 inside the parentheses? So the first thing I need to point out is that log is undefined for negative values and 0, which means that x plus 3 should be greater than 0. That's the domain. Now, solving this inequality by subtracting 3 from both sides, I get x greater than negative 3, which I can write in interval notation as negative 3 infinity. Okay, so that's going to be my domain. All right, so let's put that in here. Now, what about the range? Remember that logs are powers, and you can have any power you want. You will compute it. So there's no problem. So range is always going to be negative infinity to positive infinity. Now, what about the vertical asymptote? So vertical asymptote happens if you make the argument of the log equal to 0 and you solve that for x. So x plus 3 equals 0. That will give you, by subtracting 3 from both sides, x equals 3. So that's the vertical asymptote. Now what we need is come up with, we already know that the asymptote is x equals, sorry, negative 3 right here. That's a mistake. There should be negative 3, and so it should be here because I'm subtracting 3. Okay, so I've got the negative 3 for the asymptote, but now I need 2 points. So how can I find these 2 points? So this is going to be x, and then this is going to be log with base 2 of x plus 3. So the first thing I need to ask myself is what x value would I need to plug in over here so that this whole thing turns into 1? Because remember that log of 1 is always 0. Well, if I set x plus 3 equal to 1, so if you solve x plus 3 equal 1, by subtracting 3 from both sides, you can see that that's negative 2. So if I were to plug in negative 2, what do I get? Log with base 2 of negative 2 plus 3, but that's 1. And again, log of 1, that's why I chose it. With any base, it's just going to be 0. So I already have 1 point here. What other point would work? Well, if I had a 2 here instead of x plus 3, that would also work because log of 2 with base 2 is 1. So when is x plus 3 equal to 2? How about that? So if I make this equal to 2, you subtract 3, that gives me x equals 2 minus 3, negative 1. So negative 1 would be the next possible value. So if I were to plug it in, that'll give me negative 1 plus 3. And that'll give me log with base 2 of 2. Now, what is that? Again, remember the logs are powers. 2 to what power equal to 2? Well, that would be 1. So what you're looking for is your first point, solve for whatever this is, okay, equal to 1. And for your second point, again, solve whatever this is equal to the base. So if the base was, for example, 3, we would set x plus 3 equal 3 and solve that for x for the second point. If the base was 5, we would solve x plus 3 equal 5, and that'll give us a second point, okay? So now I have 2 points. I have negative 2, 0, and I also have negative 1, positive 1. Okay, so let's see if I can graph that. So first the asymptote at x equals negative 3. Now select the log tool first. So we highlight that, okay. And then we want 2 points. So at negative 2, we see that that's 0. And at negative 1, we see that that's positive 1. And there is my log. And notice how this log is just a translation of the log without plus 3. Like if you were to draw log of x with base 2, that would be a translation 3 to the left. If you remember the translations, the plus 3 is responsible for moving the graph 3 units to the left.